Okay. And you have seen inequalities, back in your Algebra 1 days, right? When we are solving inequalities, we basically treat this symbol, the inequality symbol, like it was an equation, okay? So let's go ahead and solve this first one. So when you treat it like an equation or like an equal sign, you can basically add and subtract, like plus 3 to both sides and so on. So here we are going to do plus 3 to both sides. So we're going to get 5x is greater than 4x plus 5. Subtract a 4x, and we get x is greater than 5. Now, when we solved equations, we got answers like x equals 2, x equals -4, right? So you only had one number, one value that works in the equation. But here, my solution is x is greater than 5. So any number that's greater than 5 works in this inequality, right? So how many solutions is that technically? Like an infinite number of solutions. So we have to have a way to represent it, and we do that on a number line. So here we go to x, we go to where 5 is, and because this is greater than, we're going to put an open circle, and I'll talk about that in a minute. And then we want the greater than, so we're going to make an arrow to the right. Okay, now a few things here. If your inequality is less than or greater than like this, you get an open circle. If it's less than or equal to, greater than or equal to, you do a closed circle. And as far as making your arrow, technically, right, like it's like this. But if you have a pencil and you're working right on the number line, it's very hard to see. That's why I like to do it like a hairline above. And then some people like to do this, okay? I do like when the circle is like on the number, just so there is less discrepancy. But, as long as it's very, very clear and there is no discrepancy or ambiguity, I'm okay with it. Okay, so let's take a look at another one. So here we're going to add 15. We're going to get 4x is less than or equal to 36. So x is less than or equal to 9. This time it's less than or equal to, so it's a closed circle, and we're going to go this way. Okay? So for the first one, right, obviously 6, 7, 8, 9, all of these numbers work. But also, so does 5 work?
No.
No, but what about 5.01?
Yes.
Yeah, 5.000001? Yeah, okay? And then here, like 8.99, 8.999, and also 9 will work, okay? All right, so if you're multiplying or dividing an inequality with a positive number, nothing happens. But if you're multiplying or dividing by a negative number, the inequality flips or reverses direction. Good. So take a look here, for example. I'm going to divide by -4, divide by -4. So x will be less than or equal to 6. Okay, we go to 6 this way. Okay? Okay, here, what am I going to do first? Multiply both sides by 5. So I get -15x less than or equal to -4x plus 22. Add the 4x, so I get -11x less than or equal to 22. Okay, now I'm going to divide by -11, divide by -11. Does the inequality change direction? Yes, it does. So x is greater than or equal to -2. Okay, so we go to -2, and we go that way. Okay, and that's pretty much lesson 5. Okay. So let's move on a little bit to lesson 6. We're going to do the first half of this. Those were all simple inequalities. But when you have a compound inequality, that's when you have two inequalities and two conditions that need to be met. Okay? So, and those two inequalities are joined by either the words and or. Okay, so take a look at this one. This is an AND inequality. What this is telling you is x is greater than or equal to -4. So look, that's here. Greater than or equal to -4, that's this way, right? And x is less than or equal to 3. So 3 is here. Less than or equal to, that's all of that region. Now the situation is your number has to satisfy both of these. So it's just this overlapping region here. Okay, so the number has to be both greater than -4 and less than 3. Now, oh shoot, I should have made that an open circle here. But I'm actually going to show you the more efficient way of doing it. So x is greater than -4 and x is less than 3. This had to be an open circle. Sorry about that. So more efficiently, we just do the two dots and we connect them with one line. Okay? So it's less like, scribbling and whatever. Okay. Now, AND inequalities are also written like this. Okay, so for example, this one, I can write it in more concise form. I can say, like, for the right-hand side, x is less than 3, right? But also, x is greater than or equal to -4, right? Now, if you start reading it from the x and go this way, kind of like Hebrew, x is greater than or equal to -4. Do you see? That's a more concise way of writing the same thing. Because look at what this says. If you start reading from the x, x is greater than or equal to -4, x is less than 3, right? So that's a concise way to write an AND inequality. So here's another example of an AND inequality. To solve it, I need to isolate x. So I subtract 8. I get -20, 4x, and 14, right? 24, oh my goodness, thank you. So now I'm going to divide everything by 4. Do I flip the inequalities? No. So I'm going to get -5, x, and 6. So x is greater than or equal to -5 and less than or equal to 6. So -5, 6, it goes in between, right? So for the AND inequality, when you write it like this, both of these has to be, less than, like they need to be facing the same direction, okay? All right, so
Isn't it like if, let's say x was, greater than 6, and it was less than 5 and they go away. Is that no solution?
That's an OR inequality. Yeah, that's a different one. Exactly. Yes. If it's AND and it's like that, then it's a no solution. Yes, good. Right. So yeah, two different things. I'll talk about that in a minute. So here for this one, let's add 2 everywhere. So -12, 3x, -3. Divide everything by 3. And I get -4 is less than x is less than -1. So we're going to go between -4 and -1, and it's that tiny little region there. Okay, let's do this one. Add 7, so we get 15, 3y, 30. So we get 5 is less than y is less than 10. Okay, questions? Okay, when you're doing this, you can still do this on lined paper, right? It doesn't have to be graph paper because it's just a number line. Okay, now those are AND inequalities. Now let's talk about OR inequalities. But before we do that, let me talk about a scenario here. Suppose D. Toledo was holding an event, okay? And you could go if you were older than 15 years and and younger than 17. Okay? So older than 15, younger than 17. So that means if you're like, if you already turned 15, even if you turned 15 yesterday, you could go, right? So who in here could go to that event? Lots of people, right? Okay. So now, suppose, you're going to get like a lot of 10th graders, a lot of 11th graders, right? Okay, but now suppose another event says you have to be younger than 15 or older than 17. Now who can go from here? The 9th graders can go. Some 12th graders can go, right? But do you see what a different scenario those two are? So one is an and inequality. The other is an or inequality. All right? They are disjointed. The or inequality, they are disjointed groups. Okay, so here is an or inequality. Okay, so take a look at this one. You've got x is greater than or equal to 5 or less than -3. They go in opposite directions, but you know what? You only need to satisfy one of them in order for the number to work, right? So 6 works. It doesn't have to satisfy both of them because it can't. Okay, so let's take a look at some of these. The good thing about these is you get two like mini inequalities, right? So here we're going to divide by 5. So we're going to get dividing by 5 is the same as multiplying by 1 over 5. So we get j greater than or equal to, this gives you a 3 over 2. Here, I'm going to divide by -3, which is the same as multiplying by 1 over -3. So I'm going to get j is greater than, I keep writing y. J is greater than or equal to -7 over 5.
Yeah, when you
Oh, yes. Here. Oh my gosh, thank you so much. My mind wandered for a minute. But in between, you have to have the word or. Okay? All right. So let's graph this one. So j is greater than or equal to 3 over 2, which is 1.5. Or less than or equal to -7 over 5, which is what? 1 2/5. Okay? Awesome. All right, go ahead and do the next one, please. Mm-hmm.
Can we on equipment and stuff, is it fine to also write it as a decimal?
You can. I always prefer fractions to decimals.
For the plotting, it's easier to.
Yeah. So mentally, you can think of it as a decimal, but you could still leave the answer as a fraction. All right. So go ahead and do the next one. Okay, what is k less than here? -16 over 5. Or it's greater than or equal to what? How much? 1 over 21? Just 21. Because you're going to multiply by 3 over 2. Right? You multiply by 3 over 2. The 2 and the 14 simplify to 21. So here, I forgot to modify my number line here. So I'm just going to make these double, and it's still going to go over. But on tests, if I give you a number line, they'll be numbered for properly. This one's still going to go over, which I guess for this one time it's okay. So 21 is here. And it goes this way. And then negative 16 over 5 is how much? It's 1 and 1. 3 and 1/5, right. So negative 3 and 1/5 here. Open that way. Okay.
It's not like exactly like.
Yeah, I mean, you're going to eyeball it, right? So the thing is, it has to be between like the right number of digits, okay? Okay, let's take a look at this next one. So here I'm going to multiply by 3 over 2. So I'm going to get that x is less than how much? 9. Here I'm going to add 1. And then so I get x is greater than negative 2 and an or in the middle. Okay, so take a look at this one. X is less than 9. Okay. If you're using a pen, don't draw this yet. X is less than 9. Or x is greater than negative 2. What is it? All real numbers. Because it only has to satisfy one of them. It could either be less than 9 or it could be greater than this, which means it's the entire number line. So we say all real numbers.
Isn't that like XER or something?
Uh-huh. Okay, it's all real numbers, or you can say all reals, or the symbol for all real numbers is a double barred R, like this. Now, here, when you get all real numbers, you don't have to do that. You can just do, whoops, a straight line is better. You can just do this, okay? Because it's all real numbers. All right, now, suppose you have an AND inequality, okay? Suppose you have an AND inequality, and it looks like this. X is greater than or equal to 1, and x is greater than or equal, or just greater than 5. What does that look like? X is greater than or equal to 1 is this. X is greater than 5 is this. So what's the region? What's the answer? If it's an AND inequality. If it's AND.
Oh, no. It would be x is greater than 5.
X is greater than 5, right? It would just be this region. Because if it's AND, it's got to satisfy both of them. If you're here, you only satisfy this one. If you're here, you don't satisfy any of them. If you're here, you satisfy both of them. X is greater than 5. Now, suppose you have an and you get something like this. X is greater than or equal to 1, and x is less than negative 1. What is that? That's no solution, right? Because you can't be both greater than 1 and less than negative 1. So that will be no solution. Yeah? Okay. Questions? There was a question here.
It's a no solution just if they don't.
Yeah. Okay, now, before I get you guys to start on your homework, we're going to stop here, actually.